All right, so if you look at today's notes, you see it says day 3. So we're doing the same kind of thing with one minor difference. It's equal to something now, isn't it? So no longer are we just factoring it, then we need to solve it. Okay, so like I said, everybody's going to do one problem, and then we'll call it a day. Now I want you to notice something. 1 through 4 on your warm-up is the same as 1 through 4 on your notes. Does everybody see that? Do you see that the difference in the warm-up is there's no equal sign? And then in the notes, there is an equal sign. Okay, so once we get down to the notes, basically we're just going to copy what we do in the warm-up, and then we're going to add one more step to it. Is that okay for everybody? Yes? Do I have a volunteer that wants to start with number 1? Ready? Okay, first things first, do you have a GCF? Nope. Does it start with a 1? So we're going to slide this to the back. What's the new problem when we do that? Okay, so we're looking for factors of that will, wonderful, what factors of 6 will add to 5? Okay, now the common mistake here, folks, is somebody tried to tell me 6 and 1. 6 and 1 subtract to 5. They don't add to 5. Okay, what do we know about my symbols here, Dylan? Okay, what did we actually start this problem with? Nope. So we need to divide by 2. Does 3 divide by 2? It does not. So we're going to move the 2 out front. Is that okay for everybody? We following all right? Dylan, does 2 divide by 2? And we get, okay, so there we go. That'd be number 1. Anybody for number 2? All right, Luke. Do you have a GCF, sir? No, you don't. It has 3 terms, and it does not start with a 1, so we need to slide and divide. What is your new problem when you do that? Wonderful. So you're looking for factors of that will, nope, add to 17. Factors of 60 that will add to 17. What do you think? 15 and 4. Symbols need to be same or different, sir? Okay, what did we actually begin this problem with? So we need to divide by 3. Again, remember, I circled that 3 up there for a reason, so I can see it. Oh, it's not 15 and 4. You're close, Luke. It's not 15 and 4, though. Thanks, guys. $60 divided by, what are you trying? 5 and 12? That'll work. And both minuses again, sir, right? Okay. All right, so now what did we actually begin this problem with? A 3. So, Luke, are we okay with dividing by that 3? Okay, does 5 actually divide by 3? So we're going to move it out front. Does 12 divide by 3? And what do you get? There we go. Looks good. Anybody for number 3? All right, Cody, does it have a GCF? Nope. It has 3 terms and it starts with a 4, so what are we going to do with it? Okay. What's your new problem? So you're looking for factors of that will, wonderful, factors of 20 that will add to 3. What are some factors of 20? Those don't add to 3, do they? Do those add to 3? There's only one more set of factors. Do those add to 3? Are there any other factors of 20? This thing has no solution. Nothing will work. Now, there's a reason I've waited till now to give you one of these problems, because I know you guys. If you get to a number and you can't find the factors, you're just going to automatically write no solution. You actually have to go through it and find all the factors and make sure none of them work before you write no solution. Is that okay for everybody? Yeah? All right, number 4. You ready, Savannah? What do you think? Okay. What's my new problem? Okay. Factors of that will subtract to 8. Is that okay, Savannah? What do you think? 9 and 1. What do I know about my symbols? And the bigger one has to be... Okay, how's everybody doing there? So far, so good? What did we actually start this problem with? Does 9 divide by 3? Okay. Does 1 divide by 3? Nope, so we're just going to move that to the front. How's everybody doing? Everybody's A-okay? You sure? Can you fill in the next part of your notes, please? Have you cooled down yet, Derek? Have you cooled down yet? I'm getting a little chilly. Can I close a couple? Oh, thanks, Luke. You want to close that one for me, Tyler? Thank you. All right, so tell me, first thing I need to do is find a GCF. Yep. Okay. If there's 4 terms, we group them 2 by 2. And I got to remember to bring back a grouping problem so I can make sure you guys remember how to do those. And then if there's 3 terms, that's the easy way, right? Yep, we do a binomial times a binomial. And that's only if it starts with a 1. Okay. If it doesn't start with a 1, we have to slide and divide. Is this all right for everybody? We sure? Okay. Now, look at those 8 problems I have down there for you. Do you see how all 8 of those problems have 2 different types of variables? Hold on one second. Have 2 different types of variables. There's like x squared and x, or m squared and m, or whatever other variables I chose, right? So I cannot isolate these variables because there's 2 different kinds. Yes, sir. Oh, there's only 7 on the front? I apologize, 7 on the front. But all of them have a squared term and a non-squared term, agreed? You cannot isolate that. You have to set them equal to 0. Because how do I have 2 factors that are multiplied together to equal 0? One of them would have to be 0. Good. 1 must equal 0. That's the only way 2 numbers can multiply to be 0. One of them has to be 0. So we have this thing called a zero product property. And it tells me if I have 2 different kinds of variables, like you do in these problems, a squared variable and a non-squared variable, we are going to set it equal to 0, then we're going to factor, and then we're going to solve them. Okay, we're going to set it equal to 0, we're going to factor it, and we're going to solve it. Now, I just told you that the first 4 are the same 4 that we had in the warm-up, correct? Are they already set equal to 0? Every single one of them is. Now, didn't we just factor them in the warm-up? Okay, so who did number 1? Dylan, can you read me off those factors to put down here? Is everybody okay with that? And it equals 0, correct? Now, Dylan, I now need to solve these factors. So what I'm going to do is I'm going to set them equal to 0, and then I'm going to isolate them. Now, the second one is super easy. What answer will you get for the second one? Nope. How do I... No, how do I solve this? How do I solve this? How do I isolate? There we go. Subtract the 1. And then what do you get when you subtract the 1? Hey, let him do it. Is that okay then? Folks, does everybody see that okay? Do you remember doing that on your quiz before break? Yeah? Now over here, how would I solve this one, Dylan? Okay, so then what do you get? Nope. There we go. And then what? So what is negative 3 divided by 2? So that's one possible answer. Another representation of this, folks, is just to leave it as negative 3 over 2. Is everybody okay with that? And then you also could write it as negative 1 1/2. Any of those three would be totally fine. Are we all good there? How many answers did this have? No. It had 2 answers because the highest power is 2 up there, right? Okay. Who did number 2 for me? Was it Luke? Did you do number 2 in the warm-up? Can you tell me what those factors were from number 2, please, sir? No. The factors from the warm-up. You did number 2 in the warm-up? What was our final answer to number 2 in the warm-up? So, folks, we've already done the factoring. That was our warm-up. Now I have to set the factors equal to 0. So, Luke, I'm going to go ahead and say x minus 4 has to be equal to 0, or 3x minus 5 has to be equal to 0. How do you solve that first one, sir? We add the 4 over. So x is, bless you. Wonderful. How do I solve the second one, sir? No. Don't subtract the 5. What's the opposite of minus 5? There we go. We got to add the 5 over. So 3x is now equal to 5. And then what do you get? You can leave it as 5 over 3. Can somebody tell me another possible answer? I have positive 1 2/3. Is that okay, Savannah? Yeah? How about the decimal representation? Not just 1.6. 1.6 repeating. How we doing here, guys? We sure? Positive? All right, Cody had the good one. Cody, what were my factors in number 3? We didn't have any. So if I didn't have any factors, do I have anything to set equal to 0? No, so I don't have a solution. This thing has no solution. Okay. And then, Derek, you did number 4, correct? Was that you? Oh, Savannah, excuse me. Can you tell me what your final factors were, ma'am? Plus what? Okay, so we've already done the factoring. Now you're going to set your factors equal to 0. How do you solve the first one? Good. How do you solve the second one? So she subtracted the 1 first, then divided by the 3, and you said you left it as negative 1/3. Can you give me the decimal answer for that? Say it again. 0.3 repeating. Good. How's everybody doing? Do you see how we're just adding that extra step of setting the factors equal to 0 and solving? Yeah? Is that okay for everybody? All right, so I got 3 of you gentlemen left. I've got Logan and Derek and Tyler. I told you we're only going to have everybody do one. Okay, you ready? No? Who wants to go first? Who wants to go first? Rock, paper, scissors. 1, 2, 3, shoot. No. 1. Ready? 1, 2, 3, shoot. 1. No, just 1. Who won? Who won? All right, Tyler. Here we go. We're going to... You don't want to go now? Let's go. All right. We're going to go to number 5. We're going to the back, and we're going to number 5. Now, Notice, does everybody see how there's an x squared and an x? So I can't just isolate it. I have to set it equal to 0. How do I get it equal to 0? No. How do I get it equal to 0 first? No. How do I make this side over here be a... No. I want that to be 0 over there. Subtract the 10. Now, does that 10 go with anything that's already over there? No, it doesn't. How's everybody doing here? Now, we're going to do what you wanted to do, Tyler. Which is what? Yep, multiply. Okay, so we have x squared minus 13x, and then you said negative 30. All right, what are we going to start with? We're looking for factors of that will, yep, what factors of 30 will subtract to 13? Say it again. 15 and 2. Some people try and tell me 3 and 10, but those add to 13, and I want them to subtract to 13. Same or different here, Tyler? And the bigger one has to be? Okay. So then what did we actually start with? A 3. You doing okay, Dylan, or no? And we're not going to do the one right below it, so if you need to run into the space for the one below it, you should be okay. Divide here. What do you get, sir? And then this doesn't divide, so can you rearrange that for me? What will this be? No. How we doing, guys? Are we done? We are not done. Now we're going to set these equal to 0, and we're going to solve them. What do you think here, Tyler? Yep, so I get x equals 5. What do I have to do over here? And then, what is 2 divided by 3? We can just keep it as negative 2 over 3, but what is the decimal? And that's repeating. Good. Looks great. Oh, you weren't writing as I went? Okay. Is that okay? You can just copy it down when we're done? Okay. Who's next? You're done. No, you're done. You already did one. Logan. Ready? Okay. Let's do number 12. All the way at the very end. I didn't say you were last. I said all the way at the very end. Okay. Is this set equal to 0? It is. So I got to factor it because there's an m squared and an m. Is there a GCF? 4. I can divide all of these things by 4. So what's left when you divide a 4? Try again. There you go. It's all right. So I'm going to go ahead and drop this 4 down because I'm done with it for right now. Okay? I'm done with that GCF for right now. Go ahead and slide and divide, sir. Good. We're looking for what? Good. Factors of 24 that will add to 11. Good. Same or different? And they will be good. Okay, what did this thing actually start with? Now remember that 4 is the GCF. The 2 is what we actually started with. What is 8 divided by 2? So that'll actually be m minus 4. Then does 3 divide by 2? There we go. Okay. Now, folks, this is the first one we've done with the GCF. Do you see how this 4 is out here by itself? Yes, it's a factor. So if I set that equal to 0, is there a variable with it? Does 4 actually equal 0? So this does not give me an answer, but the other two will. Derek, what do you get for that first answer then? Good. And then what do you have to do for the second one? Okay, so we're going to add the 3 over. And then? So what is 3 divided by 2? We can leave it like that. Anybody have another representation? 1.5. What's the other representation? 1 and 1/2. Good. And again, any of those 3 would be acceptable. You don't have to write all 3 of them, guys. You only got to have one of them. They all mean the same thing. All right, last one. Logan, we're going to do number 11. Does everybody see how, again, this problem has an x squared and an x? Yes? So, Logan, the first thing I got to do is get it equal to 0. So how can I cancel out this minus 2x that's over there? Perfect. And since it's a regular x, I'm going to put it underneath the other regular x. Everybody okay with that? They go together, don't they? Yes? So, Logan, I'm going to keep the 12x squared. What is 3x plus 2x? Good. And then I still have equals 2. Now, how do I cancel out this 2 that's over here? Subtract it. Now, that 2 does not go with anybody on the other side. It's got to go on the end by itself. That's called the constant, remember? Okay. Logan, my next question for you is, do I have a GCF? Something I can take out of 12, 5, and 2? Nope. And we do start with a 12, so we're going to have to slide this to the back. What do you get when you do that? Perfect. So I have x squared plus 5x. Now it's minus 24. I'm going to start with my x's. And Logan, we're looking for factors of that 24 that will subtract to 5. So 8 and 3. Same or different? And the bigger one has to be addition. Is everybody following Logan here? Doing great. Now, what did this problem actually start with? The 12. So we have to divide this by 12. But 8 doesn't divide by 12. But it will reduce. What can I divide both 8 and 12 by? 4. 8 divided by 4 is 2, and 12 divided by 4 is 3. Is that okay? Now, same thing over here. 3 doesn't divide by 12, but it will reduce. What can I divide both of those by? Higher. Yep, 3 divided by 3 is 1, and 12 divided by 3 is 4. Everybody doing all right? Okay, so the last thing I need to do here, Logan, is get rid of these fractions. This 3 has to go in front, and that 4 also has to go in front. You doing all right, guys? Yeah? And finally, since it's equal to 0, we actually have to solve these guys. All right, how am I going to isolate this x right here? What do I have to do first? How do I get this guy over there? Nope. What's the opposite of plus 2? So we're going to subtract 2 from both sides. So 3x is negative 2. Now how do I get rid of this 3? How do I get rid of this 3? Not subtracted. This is being multiplied, right? So what's the opposite? Yep. And folks, that can stay as negative 2/3. If you want the decimal, it's negative 0.6 repeating. You doing okay? Okay, last part over here. Logan, how do I isolate this x? Opposite, there you go. Add 1. It's all right. So 4x is 1. And then how do you get rid of that 4? Yep. And 1 does not divide by 4, so we can leave it as 1/4. Guys, what's a fourth? 0.25 if you want the decimal. Awesome. It is a lot of work for that one. That's why I saved it for very end. Yeah. Okay. Any questions for me? Can you pass yours back so we can copy that one down for him? Hope you guys realize that I really am diligent about not giving you a lot of homework questions because these take a while. Okay, so this is 6 problems. I think yesterday we had 5. Tomorrow you're only going to have 4. So, hold on one second. We're looking at a quiz on Tuesday of next week. Okay, quiz on Tuesday. All right, you can work with whomever you'd like. Whatever is left on there is also extra credit. If you so choose, please put on your homework. Other than that, have a good day. Take a lane.